Okay, today's lesson is 12-5. We are continuing to solve the systems by matrices. So you need to flip to that area in your notes and take a look at the spell work. Again, remember, anytime we see the multiple choice questions, we want to really pay attention because you will probably see things like this on the EOC. Okay? So number 1 says, what is the rate of change of the function y equals -7? Tevin may have already shouted out that the rate of change is the same thing as slope. Okay? When you have a y equals line, remember our Vuxhoy? A y equals line has a slope of 0. It's a horizontal line. So it is a slope of 0. You could actually even graph that on your calculator and look at that. And then number 2 goes way back. This is where we follow our flow chart to solve for m. Okay, so we draw our line down the middle. The first thing on the flow chart says, are there any parentheses? And in this case, there are parentheses. So we are going to go ahead and distribute. So bring down everything that doesn't get changed. The 2m, the plus, the 1 equals 3m plus 4 times m is 4m. 4 times -1 is -4. Okay, so that's distributing. If it helps to just cross this out so you don't look at it anymore, that might help too. The next step says, can you combine like terms on each side of the equal sign? The 3 and the 4, they're both m's on the same side, so they can be put together. So again, I'm bringing down the 2m plus 1. 3m plus 4m is 7m's. Okay, do we have variables on both sides of the equal sign? Yes. Move the variable on the right to the left by doing the opposite. So I'm going to do the opposite of positive 7m. I'm going to subtract 7m. Let me cross that out. So on the left side, 2m minus 7m is -5m. Bring down the plus 1, bring down the equals. 7 minus 7 is 0. And that leaves us with just -4. I'm going to come over here and rewrite so that I can look at that. Okay, I'm trying to get this m by itself. So I take away the 1, leaving me with -5m equals -5. Last step, divide by -5. And we get m is +1. Okay, so that basically went through every single step on that flow chart. Okay, so on to kind of what we did yesterday. And those of you that weren't here yesterday, there were several of you not here yesterday. Everybody in here kind of got how we did the steps. The little yellow half sheets of paper are still over on the cart that have the steps for how to do this. So we're going to start by crossing this out because remember yesterday we decided we didn't really like that. So I am super excited about today, and I hope that you will be too, because this actually puts meaning to what we've been doing. The difference between today and yesterday is that we have to come up with the equations from a word problem. So before you moan and groan, don't. This actually, hopefully, will make even better sense than it did before. Okay? So let's look at example 1 and just trust me on this. Example 1 says 8 pens and 7 markers cost $3.37, while 5 pens and 11 markers cost $3.10. Find the cost of each pen and each marker. So the first thing you want to do is define your variables. Let's let P equal the number of pens and M equal the number of markers. You have to look for the two things that we're trying to figure out. Okay, and they usually tell you. And I'm sorry, this shouldn't say number. Hello, it says cost of each pen. So cost of each pen and cost of each marker. Okay. Look at the first sentence. 8 pens and 7 markers cost $3.37. 8 pens plus 7 markers is $3.37. You see how we made an equation out of that? Next sentence. 5 pens plus 11 markers equals $3.10. So that's where you get the two equations. You have to find them from the word problem. So let me bring these over here. 8p plus 7m equals 337. 5p plus 11m equals 310. And then we're going to do like we did yesterday. Okay, so we're going to set this up on the matrix of our calculator. Again, if you weren't here yesterday, just hold on and trust me, we'll get to it. Our first matrix comes from the coefficients of these first numbers, the 8, the 7, the 5, the 11. I'm going to show you how to put that in your calculator. Then you're going to put the all-important inverse, that -1, and then our second matrix comes from all of the numbers to the right of the equal sign. Okay, so in your calculator, it should look like this. So let's go put that in. Okay, on your calculator, you're following the steps. You're going to hit alpha and zoom. This is a 2-row, 2-column matrix, the first red matrix. The 2 and the 2 are already highlighted, so I use my arrow to go down to OK, and I hit enter. Now, don't hit enter for a long time here. 8, use the arrow over. 7, use the arrow over. 5, arrow. 11, arrow. You must get out of that matrix. Okay? So this has the coefficients of the pens and the markers for both equations, 8, 7, 5, 11. Then we hit the inverse button. Right here, it has x to the -1. You're going to push that button, and it should put up this little -1 for you. Then we need to enter the second matrix, the stuff on the other side of the equal sign. So we do alpha, zoom. This time we have 2 rows but 1 column. So on column, I go down to 1 and I hit enter to highlight it. Then I arrow down to OK and hit enter. You'll know if you did it correctly because you'll see things in the right order. And this is where I put in the 3.37. Do not hit enter. Use the arrow. And 3.10. Now hit enter. And you see that it gives you 0.29 and 0.15. Now yesterday we wrote this, we wrote this as an ordered pair of 0.29 and 0.15. Today we're going to talk about what that means. Look at what your first variable was. It was P that stood for the cost of pens and M that stood for the cost of markers. So now, this is why I get super excited about this, because we can say it's 29 cents for a pen and 15 cents for a marker. Okay, so each marker costs 15 cents, each pen costs 29 cents. So now, not only do we know that, okay, when lines cross, we intersect, we get one specific point. Now that specific point has a meaning. Okay, so I realize this takes me a whole lot longer for me to explain than for y'all to actually type in. Let's try a few more. Next problem. A movie theater ticket sells for $8 each and senior tickets for $6 each. One evening, the theater sold 525 tickets and took in $3,580 in revenue. How many of each type of ticket were sold? So start by defining your variables. Okay? I don't like using T's because they look like plus signs, so I'm going to just switch back to X's and Y's. I'm going to let X be a regular ticket, and I'm going to let Y be senior ticket. Okay, now this one's not quite as straightforward as the other one. You might start doing an 8 and 6 and that kind of stuff, okay? That's fine, but let's look at what we have. We have an equation, we have something that talks about the amount of money that was made, and we have something that talks about the number of tickets that were sold. So, when you collected $8 for every ticket and $6 for every senior ticket, how much money was collected? $3,580. This is our money statement. $8 for a regular ticket and $6 for every senior ticket that was sold gave them a total of $3,580. Now the next equation feels weird, but it's actually easier. The number of regular tickets plus the number of senior tickets, when you just counted tickets, 1, 2, 3, 4, 5, there was a total of 525 tickets sold. Those don't have a value assigned to them, that's just a quantity. Okay, you'll see several problems like this, and you just kind of get used to setting them up this way. So 8 plus 6y equals 3,580, and x plus y equals 525. So there's your matrix. There's one matrix, and there's the other. So on your calculator, you're going to need to make it look like 8, 6, 1, 1. You're going to hit the inverse button. Your second matrix will be 3580 and 525. And I'll tell you, one of the biggest places that people make mistakes here is that they accidentally miscopy the numbers. Okay, so let's put this in. Alpha, zoom. We need a 2 by 2 first. Go down to OK. 8, arrow, not enter. 6, 1, 1. Make sure that looks like it's supposed to. Hit the inverse button. Then our other matrix, alpha, zoom. Now we need a 2 by 1. So leave the row the same, but we're doing it one column. Arrow down to OK. And we have 3580. Use your arrow, not enter, and 525. Now you can hit enter. And you get 215, 310, and you might be going, oh my gosh, am I supposed to have such a big number? Yes. Remember what this means. Now we have meaning in these. So where yesterday we wrote an ordered pair of 215, 310, today these have meaning. This is a regular ticket and this is a senior ticket. So we can say there were 215 regular tickets and 310 senior tickets that were sold. And you can even check yourself. All together, does that equal 525? Yes. And then if you do 215 times $8 a ticket plus 310 times $6 a ticket, you should get 3580. Okay? So again, kind of up to you to come up with the equation, but after that, it's the same as what we did yesterday. So number 3, the length of a rectangular field is 12 feet longer than it is wide. The perimeter is 76 feet. Find the length of the field. So I'm just going to use L's and W's. I'm going to let L be the length, and I'm going to let W be the width. So my first equation, the length is 12 feet longer than it is wide. The length is 12 more than the width. Okay, look at that one. You should already be noticing that something's a little bit wrong with that. Okay, we don't have just one variable on the side. Remember that these have to be in standard form. Then we have the perimeter is 76. And you might be going, what do I do? P equals 76? No, because perimeter is not one of our variables. Length and width are. So if you look on a formula chart, the formula for perimeter is 2L plus 2W. Think about it. If you have a rectangle, you have two lengths and two widths when you find the perimeter. Okay, so your second equation actually comes from the perimeter being 76. You say 2 times the length plus 2 times the width is equals 76. So again, before we can go to the matrix, go back to this equation. It doesn't have the L and the W on the same side. Yeah. But before you freak out too bad, can we move the W over? What happens if it crosses that line? Hopefully you know that this becomes L minus W equals 12. All you got to do is just move that over. No big deal. Okay, so now we have our matrix of 1, -1, 2, 2. Inverse. Your second matrix will be 12 and 76. Okay, the coefficients. So you're going to type that in the calculator. I'll give you a minute to do that. If the substitute would please push pause and allow the students to work this for a minute. Okay, you should have your answer when you typed that in. You got 25, 13. Again, remember this is why you define your variables at the beginning. The first variable is the length, the second variable is the width. So, all it asked for was the length of the field. So you would just say the length is 25 feet. Okay, and you can double check. Is 25, 12 more than 13? Yes. If you add up that perimeter, will you get 76? Yes. Okay. These just take a little bit of practice. By the time we're through with this, you're going to have seen several of these over and over and over again. You're going to be like, oh yeah, this is one where we set it up like that. Okay. For example, number 4 is very similar to number 2. Okay, so let's look at it. Jack has $3 in nickels and dimes. So already be thinking about what your variables are and what their value is. He has twice as many nickels as he does dimes. How many nickels and how many dimes does he have? So I'm going to let N be nickels and D be dimes. Okay. So again, we're going to have a money equation and we're going to have a quantity equation. So let's start with the $3. What is a nickel worth? How much money? A nickel is worth 5 cents. So if you're counting money in your hand and you have nickels, you're going 5, 10, 15, 20, and so on. Each nickel is worth 5 cents. And dimes, when you count that to see how much money you have, you go 10, 20, 30, and so on. Each dime is 10 cents. And when you got finished counting your money, or when Jack got finished counting his money, he had $3. Okay, notice that I put the decimals in place so that we would actually use that as money. Then the next one's a little bit trickier. It says he has twice as many nickels as he does dimes. And a lot of people have a tendency to put that nickels equals, two nickels equals dimes. Okay, if I want my nickels to equal my dimes, if I want my nickels and my dimes to be equal, which one needs to double? That's kind of how you have to ask yourself. He has more nickels right now. He has twice as many nickels as he does dimes. So when we're talking about an equality, we would have to double the amount of dimes in order for them to equal the nickels. This one often trips people up. They very often do it backwards, okay? And that's what my brain does. I always put the two variables equal and then say, okay, which one do I need to fix? Okay, so if he has twice as many nickels as he does dimes, in order for them to be equal, we've got to double our dimes. And then look as I read it. The nickels equals twice the dimes. Nickel equals twice the dimes. And that's actually exactly what the sentence says. Okay, but here again, let me stop for a sec. Y'all digest this. Get your two equations. 5 cents for every nickel, 10 cents for every dime is $3. And then we have twice as many nickels as he does dimes. So his nickels are twice the dimes. Maybe it would help if you write it that way. Nickels are 2 times dimes. Okay. But then when we look at the second equation, again, the N and the D aren't on the same side, so you have to be real careful. You can't just go putting in a 1 and a 2. If I want this to be by itself, or if I want the N and the D on the same side, okay, bring over that 2D and look what you're left with. You're left with a 0. That's okay, and we need that 0 as a placeholder. So your matrices are 0.05, 0.10, 1, and -2. Stop for a second, make sure you know where those came from. Okay, we've got our nickels and our dimes. Then we hit the inverse button in our second matrix. We have a 3 and a 0, and that's okay. Leave that 0 there as a placeholder. That's important. So again, if the substitute will please push pause while you all calculate this. When you type this in, you should have gotten 30, 15. Go back to the meaning. This is why this is so cool, because when you're like, oh, when are we ever going to use this? Why do you ever need this? Okay, here's why, and here's how it works, okay? These now have a meaning. This is your nickels and your dimes. So Jack has 30 nickels and 15 dimes. And in your smartness, you just figured that out. Okay. All right. The substitute is now going to hand out the quick check for today. This lesson should have taken about half of class. You have the other half to work on your quick check. I expect that you will get this done and you will turn it in today before you leave. You need it for the calculator. I mean, you need the calculator to do it. I don't mind if you work together. That's fine, but I expect you to be working and be focused. Okay, don't have the electronics out. The substitute will make notes of that for me, okay? Be working on your stuff. If you're listening to music and it's helping you focus, that's one thing. If you're playing a game on your phone, that's a whole different thing, okay? So please work on this quick check and get it turned in before you go today.